Hi, hello, welcome you all for my channel Knowledge Center. I am Assistant Professor Sharan, going to explain you regarding the programming in microcontroller. This session will be helpful for engineering as well as diploma students. Microcontroller 8051 is the small computer on a chip, and this is used to write a program and execute the particular task. So here I am going to take few examples. Let me explain two programs and with in detail means I am going to tell you how to understand the logic and how to execute it. Okay, how to execute it in terms of a program. So let's have a look on the first program. So write a program to move a block of n bytes of data from source 20H to destination 40H using internal RAM. So it means using internal memory. We are not using any external memory here. You just need to use an internal memory, and they have given the address here. Source is 20H and destination is 40H. We need to write a program to move a block of n bytes of data from 20 to 40H. So we can easily understand here by having this block. So we can understand that 20H is a source wherein we need to give an input. So here address of source memory is 20H, and they have mentioned that n bytes of data has to be moved. N bytes means you can take any number of bytes. I am here considering 5 bytes. So 20, 21, 22, 23, 24. These are the addresses. At this address I am giving a data. So user has to give this data 1A, 2, 3. These are some sample data. Right. So now these data has to be moved to 40H. 1A should be moved to 40H. 23 should be moved to 41H. 54 should be moved to 22H, like that. So this is what we need now. 40H. So 40 to 44. These are the destination. I need to move this data here. This is what we require. So first you need to understand what we need to do. So this is what we need to do. Let's see how to do this, how to achieve it. After that we can go for writing a program. So here consider this is 20H address, and there we have a data 1A. We need to transfer it to 40H, but we can't do it directly. As we already discussed in my previous video, register to register cannot be moved, right? So we need to consider accumulator. In between you should take accumulator. This data 1A has to be moved to accumulator. So what we need to do is first consider this and take it into accumulator as shown here. Just move that to accumulator. So accumulator will get 1A. From there we need to shift it to 40H. So this is what we need to do. uh, get 20H. The content of the 20H is the data 1A that has to be given to accumulator, and from accumulator again that has to be moved to 40H at 40H. So this is how data can be transferred or moved, right? So to do this we need to have an algorithm. So let's see what is the flow, how to do this. The same thing has been explained here. Look at this. First we need to start the program. As I already told in my previous video, every program will have start and end directive. So start has to be done. After that you need to allot source address. Your source address is 20H, so assign that source address to one register. Then allot destination address, that is 40H, to another register, and allot count. Count is nothing but how many data you want to move from this source to destination. We want 5, so you need to allot that 5 to any of the register. Then comes the logic. The fifth step is the main logic here. So we have made all the allotments here. Then go for the fifth step. This says that move the content of source to accumulator. So whatever the content I have here, that has to be given to accumulator. Then next step, sixth step will be copy this content what we have in accumulator to destination. Copy it to destination. So copy this content to destination. Here one thing you need to understand, copy is nothing but it's just a move is nothing but it's just a copy. Okay, so then after doing this we got the first data into 40H. That's good. Next I need to go for the second data. So second data we had at 21H, and that has to be moved to 41H. So for that we need to increment it. Okay, so you should increment those source and destination addresses and then check whether all data has been transferred or not. You need to check it. If not, you should repeat the step 5. Again you have to repeat this step 5, 6, 7. Okay. Then after completion of it, you need to end it. Okay. So now let's see how to write a program for this. So to start, we have to start it with org and the address from where we can store the program. So org 2000h. I told you that we can store it from 000 to any of the address up to FFFF. So I have taken 2000, means whatever the program I am writing here, that will be stored in the 2000h memory. Okay, that is the code view, means that is the storage for a program. Now first 3 step is to allot the address. So what I did here is move or not comma hash 20h. So we are allotting the 20h to or not, that is the source address. Same way we need to allot the destination address. Destination address is 40 and that let me take it in R1 or R2, any of the register. So here I have taken R2. Okay, concentrate here. I told I should take a 40h now, but here we have taken 6 here. It means I am just trying to move the data, 6 datas. Okay, after that I will assign the 40h. So we can change the positions of these these instructions. I can write this first I can write this line, second I can write this line. So we can alter this because we are just anyhow defining the addresses to particular registers. We are allotting the addresses to particular registers, so we can just alter, reshuffle this, not a problem. So what I have done, first I have taken the source into R0, next I have taken count into R2, then I have taken the destination address into R1. Here count is 6, means we can take 6 datas, we can transfer 6 datas. If you want, you can change it as 5 also, not a problem. Okay, so first thing is to allot the numbers. So we allotted the addresses as well as the count. Now we need to you need to write the logic. So the logic says that, you can recall the previous slide, the logic says that take that content from 20h to accumulator. So to do that, we have this instruction, move a comma at or not. So this is most important. This we call it as an indirect register addressing mode. As I write at or not, it says that r naught is 20. At 20, what do you have? That is 1a. That was the input we have given. So that 1a is the data that will be given to accumulator. So this is what going to happen. So whatever I written after this semicolon here, that is nothing but just a comment. So it will not execute this. This is just a comment to understand. To make it clear for you, I have written it here. Okay, these are not the instructions. Only this portion is the program. After semicolon, whatever you write, that will be considered as a comment. Okay, so a will be assigned as 1a. I got that first data into accumulator. Now we need to move it into, shift it into 40h. So now what you need to do is, you should write like this, move at r1 comma a. It means whatever we had in a, that 1a will be given to at r1. r1 is assigned as 40, so at 40 I will get 1a. So first data, what we had 1a, that is shifted to 40h. So we got 1a at 40h. This is what the concept is. Now after doing this, now we need to go for 21 and 41. Okay, you need to increment this because I want to collect the data from 21 and give it to 41. So both R0 and R1 should be incremented. So we will write an instruction called increment R0 and increment R1. So both will get incremented. After this, you need to check whether we have transferred all data or not. So to check that, we have a conditional jump instruction, that is decrement and jump if not 0. So decrement the resistance R2, and if it is not 0, then jump. So where it has to jump? It has to jump to this label, whatever we have written here. So this label is written back somewhere here. I'll tell you why we have written it here. See, we'll decrement this R2. R2 will become 5. It's not 0. So it means that still there are 5 numbers which has to be transferred. Okay. So if it is not 0, then we have to go back. So where should I go back? Already I have incremented that addresses to 21 and 41. So I should just go to that and take it into accumulator. I should take the data from 21 to accumulator. So for that, this is the instruction we have written. Move a comma at R0. R0 is 21 now. It is incremented. So at that 21, whatever I have, that will be given to a, right? And then it will be copied to 41. So we should jump to this line. So write that label here, loop and colon. Okay, then we get this. we'll come back to here and we'll take 21 data into A, and that will be given to 41. Then again increment these two so that it will become 22 and 42. Next it will be pointing towards the next data, next address. Okay, then again decrement this R2. If again it is not 0, it will come back here. So it will be repeated unless and until we get all 6 data transferred. Okay, so once we transfer that, we need to stop it. So to stop this, what we do is we will create a short jump. Short jump, S jump is nothing but short jump. S stands for short. Okay, and we return a label here. So short jump means this is called unconditional jump. There is no condition here. It is just mentioned as a short jump. You just jump. Okay, jump wherever the label written. You should jump to the label written in this. So here we have short jump, and where should I jump? To this label here. And where did I return it? Just beside that. Okay, here. So it will be in this loop only. Okay, so that will be the way of ending the program. After that, we should just write end. This indicates end. Okay, this is the directive. Even org is a directive. So this is the simple program to transfer n number of data from source to destination. I hope it's clear for you. If this is clear, just like the video and comment on it. Don't forget to share among your friends, sir. Okay, let us take one more example now, one more program. So look at this. Write a program to exchange the source block starting with address 20H, that is internal RAM, containing 5 bytes of data. Okay, so 5 data has to be exchanged with the destination block starting with address 40H, internal RAM. So both are internal RAM. 20H is also internal RAM, 40H is also in internal RAM, and you need to write a program to exchange the source. Okay, so there are 5 data stored at 20H and 40H, and you need to exchange it. Write a program to exchange it. That's the point. So let's see. Here we have 20H and 40H, and I have written some data here. So these are the data. 5 data I have written. Okay, here also I have written some 5 data. This is before execution. Once you execute the program, what I need to get? Let's see that. So after execution, I should get it like this. So whatever the data we had at 40H, that should be given at 20H, right? I got it here. And whatever I had at 20H, that should be at 40H. I got it here. So it is exchange of data between two registers. So this has to be done. So you can compare it. Everything has been exchanged here. So this is after execution and this is before execution. Okay, so first you need to understand what we need to do. What has to be there before execution and what has to be done after execution. Okay, so now let's see what is the flow. Again 20H, the data has to be taken to accumulator. So move that to accumulator. To do this, we can use an instruction called move. I've taken that 1A to accumulator. And now what we need to do is, in 40H also we have a data. So here we need to give input at 20H as well as at 40H, because I need to exchange it. So at 40H I have given something. So at 40H we have 12. Right. So now what we need to do here is, you should make an exchange between accumulator and 40H. Because accumulator is having the data what we have at 20H. This is copied here. Now let me exchange these two. So you can look a picture here. So once I exchange these two, I will get 1A here and 12 in accumulator. Okay, so I got 1A at 40H. Okay, and in accumulator I will get 12. So half of the work has been done now. Means this 1A is given to 40H. Yes, I got it here. Now what is the next process is, I should take this 1, 2, that is 12. This has to be given to 20H. But here still this 12 is not given to 20H. It is just in accumulator only. So what you need to do, from accumulator you should move to 20H. So we should move to 20H so that we will get it into 20H. So now these two data has been exchanged. So to understand this, let's look at the algorithm. So start it, allot the addresses, source address, destination address and count. So this has to be allotted as similar to the previous program. Then move the content of source to accumulator. I have taken this content to accumulator, and in between these two we will exchange. So exchange it with destination. So exchange these two, so we have done it here, exchange it. Okay, and then move the content of accumulator to source. So move the content of accumulator to source. This is the process, and check whether all the data has been transferred or not. If not, repeat the step 5. And again what you need to do, in between this you should increment. So I have written here 7 here. It means we should increment it. Okay, don't go with the number here. move content of accumulator to source. Okay, this we have to do it here. After getting this, we should increment the address. 20h has to be incremented, 40h has to be incremented, and then we need to check whether all the data has been transferred or not. If not, we need to repeat step 5. Okay, this is the flow. I hope this flow is clear. Now let's write program according to this. So how to start, how to allot, we already have an idea. Let's do it here. org, I'm taking some different address just to satisfy you guys, because I just want to show you that we can take any address. It's not just restricted to take 0000h. I'm starting with 9000. Then I'm assigning the 20h, that is the source memory, to R0. And after semicolon what I have written, I have just written it to make it clear for you guys. Okay, this is a comment. Initialize the memory address to R0. Then again initialize the destination address to R1. Then initialize the count to R2. Okay, we are giving the count value, destination address and source address to some registers. Then we should start the logic. Take that first data into accumulator, copy first data into accumulator. After that we need to exchange it with the destination. So for exchange we should use an instruction called XCH, exchange a comma at R1. So whatever the data we have taken from that 20h, that was there in A. Okay, from accumulator I am just taking it back, I am just exchanging it with the R1. R1 means 40h. At 40h whatever I had, that will be given to accumulator, and in accumulator whatever I had, that will be given to 40h. So exchange is happening here. So now what happened, 40h data is in accumulator, I should move that to 20h. So again you write this instruction, move at R0 comma A, so that the content of A will be given to R0, that is 20h. So according to the previous slide what I have explained over there, you can go through that, so the logic will be satisfied here. So first what we are doing here, we are copying the content of 20h to A, and then I'm exchanging it with the content of 40h, and A will be interchanged. So finally 40h will get the content of 20h into it, and then the content of 40h was in A, so that will be moved to 20h here using this line, using this instruction. So finally 20h and 40h, the data will be exchanged. So we should have an exchange instruction here. After that again increment that 20h and increment that 40h. So R0 R1 has to be incremented. Okay, we can't write increment 20, increment 21. We should write an increment register. So we have written register. That's the reason why we have allotted those addresses to registers. Increment R0, increment R1. It means it will increment these two numbers, 21 and 41. Then we should check for this djnz R2 loop. So decrement R2, if it is not 0, jump here, loop. Somewhere here we have loop. So again we should take that 21 data into A, then exchange it with 41, and that 41 data should be given to 21. So that is going to happen here. It repeats unless and until R2 becomes 0. Once R2 becomes 0, you need to stop it. To stop, we use AR sjump here, then end. So for any program, these two lines of the last two lines will remain same. I hope this program are clear for you. You go through this previous slide clearly so that you can understand the concept. Once you understand the concept, then you can apply the instructions and write a program. I hope this is clear for you. If so, like the video and share among your friends, and don't forget to subscribe to my channel. Thank you.